Hello, so I hope everyone's been having a fun time at home and had a good half term. I am James, I'm lower sixth, Lance Corporal, if you haven't had the pleasure of meeting me. Today we're going to do basic navigation, so using map and compasses. Very essential though, so it's quite easy to pick up, but it's very essential that you learn this, especially if you want to do D.O.V. Because, yeah, very transferable skill. So by the end of this presentation, I am hoping everyone will be able to pick up the basic skills of being able to use a lightweight compass for practical navigation. So in the field work, you use it in biennial review, and of course DOV. So as you probably know, there are lots of different types of compasses. However, the one you'll probably see at school is this star, as you can see on the screen. It is a make by a company called Silver. They're very handy. They are waterproof, which is obviously good, especially on expeditions. Very lightweight, and they always have this little string around them too, so you always keep them around your neck with your map. Very easy to use, and very essential when walking around on expeditions, because you don't want to get lost. So a bit of history, because apparently compasses have history. They were discovered around 5,000 years ago by some of the early Chinese dynasties. They were made with a naturally magnetized stone, which contained iron. As you should know, iron is magnetic, and it would point towards um, the magnetic North Pole, which allowed very easy navigation around what was a huge empire at the time. Um, of course, nowadays, because we still use them 5,000 years on, they're used in pretty much every form of transport. So whether it be land, sea, or air, they're all used in some way or another. In like sat navs, things like that, you'll see a compass. Um, but that's a list of different things that it could be used for. I think an emphasis on the military would be good, as especially as you might have to rely on a compass more in nighttime operations, because you won't really be able to see many of the landmarks, and you'll be able to have to trust your equipment when using it to navigate through possibly enemy territory or whatever. So in this section, I'm going to be talking about the main parts of the compass. There's 6 in total, and I'll be going into each of them in more detail. So the first component I'm going to be going into is the base plate, which is that transparent rectangle you can see, and the compass housing, which is that raised black circle on top of the housing. Very simple. The base has some measurements on the side, including a scale and a ruler that are just used for general map work, and the compass housing holds that magnetic needle that we'll be getting into more detail next. So the compass needle is suspended in liquid inside that compass housing, and as we all know, a compass points north. So the red end of the compass points towards the North Pole, and as it says there, in some cases the needles can be luminous, so they glow in the dark, which can obviously help during nighttime operations. So the direction of travel arrow is the arrow you can see on the base plate at the front. It's indicated on the PowerPoint, and this is pretty much, you put it on the map, and that is pointing in the direction you want to go. You direct that where you want to go, and you figure out where you have to walk from there. But obviously, I'll be getting into that later. And pretty much when you're walking, you get the red needle in the red house. I'll go into this in far more detail later. And then that direction of travel arrow is, you guessed it, the direction you travel. So the index lines are the little increments you can see all along that rim on the black circle, and they are used to calculate bearings, similar to on a compass, not a compass, on a protractor. You'll see all the different increments showing 1 degree. This is exactly the same, except you would use, say, 020 degrees north, something like that. Okay, so the orientation lines are very handy. So that compass housing that I mentioned earlier rotates. You can twist it and it'll rotate. And those black lines within the circle that are indicated on the PowerPoint will rotate with it. And you simply have to line those. When you have your direction of travel, you twist the circle until those lines are in line with the grid um, on the map, so you know exactly where north is on the map. They're very useful for keeping north in the right direction. And finally, the compass scale is the scale I briefly mentioned earlier. It is used with the other scale that will be provided on a map that you use. Um, Pretty much all compasses, well, all compasses that you'll be using will have a centimeter scale on the edge for you to measure distances, because on the map it will say something like, this is purely an example, 1 centimeter equals 1 kilometer. So you know from using that how many kilometers you're going to have to walk. And finally, so this is a picture with them all together, so you can get your bearings a bit more, no pun intended, if I had explained any locations badly. There you go. So these are the cardinal points of the compass. You might have learnt some way of learning the order of north, east, south, west. Some like never eat shredded wheat, I think is the easiest one. I think I've heard never ever support West Ham as well. But you know, it's just any way that works for you is good enough for me. So it goes from, if we're going clockwise, it's northeast, southwest. Um, and you'll see this on a compass as, so north is generally regarded as 0 degrees, and then 90 degrees is east, and then 180 is south, and 270 is west. And then between each point is northeast, southwest, northwest, which are exactly halfway between each main cardinal point, so each 45-degree increment. So bearings are taken using these cardinal points that we just learnt. They're measured, as I said last time, clockwise, 0 to 360, because it's a full circle. And which direction you want to go in is that number. So 0 would be going exactly north, where if it was 180, going exactly south, and then anything in between. You must also, however, use 3 digits. So if you were going 45 degrees, so northeast, sorry, you would say 0, 45 degrees northeast, not just 45 degrees. Don't know why, but that is a rule. So on maps, something you will realise is that all the text is all oriented one way, and that's so if you're reading it, then the top is north, and all the grid lines will be in line with that, and going up to the top will be north. However, these are not exact north, these are grid north, which we use in maps. There is generally some magnetic variation between grid north and magnetic north, meaning that true north is actually different to what we see. So as you can see in the presentation, in the UK, which is really the only thing you need to worry about, is around 4 degrees west of true north. So when working with maps and compasses, as I was talking about, that variation is very important. When we work with maps, we deal with the grid bearings, so we use the grid north to go off our 0 degrees and work out bearings. When working with the compass, we use the magnetic north, so we use magnetic bearings where magnetic north is 0 degrees and work off there. Obviously that means there's going to be some inaccuracy, meaning there's a simple system had to be devised so people wouldn't get lost, because 4 degrees doesn't seem like much, but 4 degrees 10 kilometers down the road is very far away from your target location. And that simple system is you just add or subtract magnetic variation degrees. Yeah, you just add or subtract degrees depending on which way you're converting it. I'll go over that in the next slide. So if you're doing magnetic bearings to grid bearings, then you subtract 4 degrees if you're in the UK, 4 degrees west. And if you're doing grid bearings to magnetic bearings, you do the other way, you add 4 degrees west, which should cancel out that inaccuracy we were talking about. So some general tips when using the compass. You want to stay away from magnetic objects or keep your compass away because it will interfere. I remember when I was doing my silver DOV, I had a magnet, just a little magnet on one of my bag straps which held my water, and that interfered with my compass a lot, and we were wondering why we kept getting lost. You want to hold it flat because otherwise gravity might also interfere with the direction of the needle, because you might, if you're holding it slightly an angle sideways, it might go more east or west depending on which way you're holding it. You do want to, obviously this happens with most equipment, try not to drop it or break it, because well, if it's broken, it's broken. but knocking it can also change the direction, like it can get stuck in one direction, things like that. Um, you want to store it because it's a magnet. You don't want it near electrical equipment, so don't keep it in the same pocket as your phone. It's a small magnet, but you don't want to risk anything. And yeah, if you knock it or drop it, there might be a leak, and you'll see bubbles forming inside the needle, the compass housing, which will lead to inaccuracies in your bearings. So you will want to get your compass replaced if you have anything like that. So this is very important. So when using a compass on a map, so when you're initially trying to find your bearing, say you're the map leader for your team on that day, you find out first where you are and find out where you need to go. This obviously, a compass calculates a straight direction, so you have to think about on the map, if you're on a windy path, you might want to do from where you're standing to the next corner as to keep it a straight line. So you keep the center of the compass housing where you are, and then move the other end of the direction of travel arrow to where you're trying to get to. And then you will see that the compass housing line, so the orienting lines that I was talking about earlier, will not be in line with the grid on the map. So you need to then rotate the compass housing so that that big red arrow, the orienting arrow, is facing north, and all of the lines are in line and parallel with the grid on the map. Once you've got that, you can then get rid of the map. You don't need that anymore. Obviously, don't throw it away. Don't be silly. Then you want to just rotate yourself whilst keeping the compass flat until the red man, or the red needle, is sitting in his house, because the big orienting arrow looks like a house, and you need to rotate until he's in his house, and then the direction of travel arrow is pointing where you need to go. I know, it's crazy. So the final thing we're going to cover is measuring distances on a map, because it's all well and good you know which way you're going, but if you don't know how far you're going, that's also, well, you can't measure or estimate the time it's going to take you to walk that distance if you don't know how far away it is. So using the centimeter scale that is on the bottom of the compass, and the scale at the bottom of the map, which you can quite clearly see on the presentation, each one of those black and then white increments, for sake of ease, let's assume that on the map that is 1 centimeter. That scale basically means 1 centimeter equals 1 kilometer. So you then measure from where you are to your destination using that centimeter ruler. You can say it was 5 centimeters away, that would mean it was 5 kilometers on the ground. Whereas on a more zoomed out map, perhaps the scale could be 1 centimeter equals 5 kilometers, meaning 5 centimeters on the map would be 25 kilometers on the ground. But that is not including contour lines. So contour lines you can also see in this example. They're the lines which signify gradient, so an incline or a decline in the terrain. Each line indicates 10 meters of elevation from the line before it. So meaning you can count the lines. Say on that hill on the right hand diagram at the bottom left, there are 4 lines, meaning that hill is 40 meters tall. So you have to include incline and decline into your journey to see how long it'll take you. Obviously it's going to take you longer if there's a lot of incline, but then again it actually reduces a lot of time if there's a decline to the way you're moving too. Well, thank you for listening. I'm hoping it wasn't too dry, but I hope to see you all soon when we can come back to school. Well, probably next year now. Other than that, yeah, hope you enjoyed. That's me out.